Try again then. Okay, Bismillah ar-Rahman ar-Rahim. Today we are going to talk about engineering economics, a very important subject by itself. We are going to cover it in 3 to 4 sessions, and of course we are going to just touch the base of it, but it's really nice to understand about the economic concepts which you perhaps will be using it, or most probably will be using it when you will be working as managers. For example, you are working in power distribution as a power distribution engineer, and you might be confronted with 2 or 3 different proposals for buying transformers, and one vendor comes to you and he says that we have a very nice transformer, its capital cost is this much, its iron losses are this much, its copper losses are this much is its lifetime, etc. Another vendor comes to you and he says, well, our initial cost is high, but we have less losses, less iron losses, less copper losses, we have very nice transformer, it needs very little maintenance, it has a long lifetime, etc. So you can see that different vendors are telling different stories, and you have to take a decision for your company. You might have to buy 100 or 200 transformers for your company, and this is concepts of engineering economics which you will learn over here. So let's see what we have in these coming slides. Not moving. Stuck here. Oh, okay. All right. So in this slides we are going to show you about something about time value of money, interest formulas, discount rate, escalation and inflation, depreciation, some classification of costs, measure of price, and eventually criteria used for project evaluation. The time value of money concept is very important in capitalist economics, and the main concept is that the money of the same dollar amount in different time periods have different values, purchasing power. And this is said because there are 3 basic reasons given. One is pure time preference, that the money available in a future period is less valuable because it is not available for use at the present. They say that human nature is that they would like to have money now rather than in future. For example, a friend comes to you and he says that I want to borrow 1,000 riyal, and you might give him, and he say that I will return it after 1 month. When the 1 month passed, he come to you again and he says that please allow me to take it, keep it for another 6 months or so. Now your natural response would be that, you know, I was waiting for this 1,000 riyal, I might have to buy a car, I want to buy a car, I have already 9,000 riyal, with 1,000 more I can get a better car, etc. So you would like to have your money now. This is a natural preference. This is called pure time preference, that money is available in a future period is less valuable because it is not available for use at the present. So you would like to have money now rather than in future. This is pure time preference concept. Another concept is opportunity cost of capital, that the money can be invested for intervals of time to earn a real return. This is the marginal productivity of capital, that you put it in, minimum you can do is put it in a bank and earn interest, which is of course haram, riba, but that you can do, or you can buy shares or put it in business and you can earn more money. So there is the opportunity cost of capital. There is a marginal or productivity of capital is there. The third concept which is used also in justifying the time value of money is the risk. that there is always risk that you will not be able to get your money back. And now this is also, we can say that, for example, giving the example of your friend again, that he borrowed 1,000 riyal from you, and there is always a chance that he may say that I didn't borrow anything, or I don't have money, and he keeps delaying you and keeps delaying you, and he may return it after maybe 5 years or 10 years, or he may never return it. So there is always a risk involved. So these are the three basic concepts: pure time preference, capital, and risk. These are the three basic concepts used for justifying the interest in the society, or the time value of money, which is that the basic is of having interest prevalent in the society, and the capitalist economy work in this way. Another concept which is also sometimes quoted is inflation, although these concepts are independent of inflation. Inflation is man-made. Inflation tends to erode the purchasing power or value of money, and this happens because when a government print more money, then the supply of money becomes more, and eventually the prices of the commodities goes up. It not only occurs due to printing of more money, it mainly occurs because the banks make loans. When they make loans, they create money out of thin air, and that's why the inflation occurs. But regardless of inflation, we can say that there are these three main reasons: pure time preference, opportunity cost of capital, and risk, that justify riba or interest in the society. Now, if we understand that there is a time value of money, then when we are comparing the projects, we might have several projects in which the benefits and costs are occurring in different times, and we have to somehow compare them. Now, for comparison purposes, we might have to take money in the future, or we might have to bring some money from the future to the present value. So if we take the money in the future, we call it compounding, and if we bring that money to the present time, it is called discounting. And we have several formulas. We will discuss 6 basic formulas which are used to equate the money in different times. So one is the single compound amount formula. The second is single present worth formula. Third, we can say, is uniform series compound amount formula. Uniform series present worth formula, or rather, sinking fund formula. And we have done uniform series present worth formula. And uniform series capital recovery formula. When we are going to discuss these formulas, we will be using these notations here. We will call P as present value, F future value, I as discount rate or interest rate. We will be using this as a synonymously, but they have some differences. We can discuss this in later time. Interest rate. N will be the number of periods. And for uniform series of payments, we will be using A for annuity. Annuity is the uniform series of equal payment. Okay. And we will be normally taking interest rates per annum, but it can be used per month also. Our formulas are general. The periods can be divided according to monthly periods or yearly periods, but mostly our discussion will be yearly period and yearly interest, etc. So let's see these formulas. Single compound amount formula is that if you have a present value, and let's say these are some periods here, and this is F value and this is pre-value, and you are at this time 0 time 1, 2 and 3, and you want to see what is the value after 3 years. So single compound amount formula says that if I is the interest rate, then the interest in the first period will be F1 is equal to P into 1 plus I. After 1 year, your P will become P into 1 plus I. And after 2 years, this future value will be again multiplied with 1 plus I. So this become P into 1 plus I square. And in 3 years, this F2 will again gain some 1 year of interest. So this will be 1 plus I power 3. So in general, we say that in N, P into 1 plus I raised to power N, where N is the number of periods, I is the interest rate, and P is the present value, N is Fn is the future value in N periods. This is single compound amount formula. Then we have the single present worth formula, which is the same, basically just invert this equation and we will have the present value. So if there is a future value given and we want to bring value, then P is equal to Fn 1 plus I raised to power N, where N, I over here is called discount rate. So you are discounting back the future values, and this is a single present worth formula. As you can see, we have, why it is single, because we have only single payments here, single payments at the future, single payment in the present. Then we have four formulas which are related to uniform series of payments. So we will see these uniform series compound amount formula first. Let's check it out. I will start writing these equations, so I can just remove this one. I will start writing these equations here in front of these formulas. We have this P is equal to Fn over 1 plus I raised to power N. This is this is first of all, this Fn is equal to P into 1 plus I raised to power n, and from here we get P is equal to Fn over 1 plus I raised to power n. Now, uniform series compound amount formula. Let's say we are over here at 0 time, and at the end of this time period we put some equal amount, start putting some equal amount of money, and this is called A. A is the annuity, uniform series of payments, and we want to know what will be the future value. What would be the future value after? So we want to know F. Now F3, let's say we want to find out after 3 years. This is 0, 1, 2 and 3. 3 years, 3 periods, whatever we have. Normally we will be working each year, at the end of each year. Now we want to find out what is F3. We can say that F3 is equal to, now this annuity A will earn interest of 1 and 2 years. So we have F3 is equal to the first annuity will have the interest 1 and 2 years. So A into 1 plus I raised to power 2, the same formula, this one, plus the second annuity will have the, so we have okay. Now let's generalize this equation and write it in terms of n. So we have Fn is equal to A into 1 plus I raised to power, as you can see over here we have 3, then here we have 2. This means that here we will have n minus 1, okay, and then we have A into 1 plus I raised to power n minus 2, and plus so on, plus the last one will be A. Let's call this equation 1 and multiply this equation 1 with 1 plus I on both sides. Multiply 1 plus I on both sides. So what we get is Fn 1 plus I is equal to A. When this is multiplied with 1 plus I, it will become raised to power n, and this one will become A into 1 plus I n minus 1, and plus the last one will become 1 plus I. Now let's call this equation 2. Now subtract 1 from 2. Subtract 1 from 2. When you subtract it, you will see that Fn and Fn cancels, and we will left with Fn into I, and this one will be A into 1 plus I raised to power n, and this term will cancel with this one, and all these terms will cancel out except that this plus A will become now minus A. And we have a nice formula here coming. Fn is equal to A 1 plus I raised to power n minus 1 divided by I. This is uniform series compound amount formula, which means that if you have a uniform series of payments going on, at the end of these series payments the future value will be a into 1 plus I raised to power n minus 1 divided by I. Okay, so we write this formula again. Here Fn is equal to a into 1 plus I raised to power n minus 1 over I. Now the next formula is the same formula. We have to collect the fund in future, some fund in future, how much we have to put each year, each period, this fund. So just invert that formula, just manipulate it, and you will get the uniform series sinking fund formula. So we have Fn and I into 1 plus I raised to power n minus 1. These terms in brackets have also names. Okay, we have, this is present value factor, this is future value factor 1 over 1 plus I raised to power n. This within the bracket is called compound amount factor, this is called sinking fund factor. The next formula is uniform series present worth formula. And you can see over here, this future value Fn, if you want to bring it back, now this has become a single payment, and when you bring this, all these series of payments in the future, this become a single payment. Now if you want to bring it to the back, to the present value, you have to discount it 3 years back from, for example, this one, 1, 2 and 3. So if it is n, you have to bring it n times. So this means that we have P, if I will say here, then I will just put it here, just this single amount, and we have single amount here, and just divide this with 1 plus I raised to power n. So we have all these things, except that we have now this term 1 plus I raised to power n coming. We have this A, 1 plus I raised to power n minus 1 divides by I into 1 plus I raised to power n. And this is uniform series present worth formula. And finally, the uniform, another formula is, finally we have uniform series capital recovery formula, same formula except that we have some present value, and we want to find out how much we have to, let's say, recover annually. We can just convert this one, and we have uniform series capital recovery formula. So A is equal to P into I into 1 plus I raised to power n over 1 plus I raised to power n minus 1. The terms in this bracket is called present worth factor, and the term in this bracket is called capital recovery factor. So this is CRF, capital recovery factor, this is PWF, present worth factor, and present worth factor is inverse of capital recovery factor. So we have seen all these formulas. These are very easy to work with, easy to remember also, and if we know how these are developed, we can see that they are not difficult at all and very useful formulas. We will see its applications in the coming examples. So let's look at those examples, and you can ask questions later on. Okay, so let's look at these examples. Here's example 1 for single compound amount formula. Jack deposits $200 in a saving account that has an interest rate of 8%. Then in 4 years time he will have how much? And simply use this formula and you will get $272. Okay, let's see the this simple example and see the magic of interest. Let's suppose that one country borrowed $1. One country borrowed $1 and didn't pay it back for, let's say, 200 years. N is equal to 200 years. And we want to see what is the future value of this. So we have P into 1 plus I raised to power n. Let's say I is 10%. Then if you put 1 into 1 plus I, which is 0.1 raised to power 200, what we get is almost $190 million. So you can see that the $1 has been raised to $190 million. And if we have $1,000 here, this will become $190 billion. So you can see the magic of interest. Ya ayyuhalladhina amanu la ta'kulu riba id'afan muda'afa. So you can see that this riba, it keeps increasing, like compounding effect is there. Now we will continue with example number 2 on single present worth formula. An expenditure of $5,000 will be required at the end of 2022, and some money must be put aside at the start of year 2018 to cover this future expense. If the interest rate is 12% per year, the present value of that future expense at the start of 2018 is, and you just use the formula and you get the value $2,837. Okay, simple application of the formula. Then we have example 3 for uniform series compound amount formula. We have mortgage bonds with a face value, this is about uniform sinking fund formula. Mortgage bonds with a face value of $1,000 must be saved in 20 years. So the future value is given and n is given also 20 years. How much money should be put into a saving account at the end of each year, annuity, to meet that bond commitment if the saving accounts pay 7%? And you just use the formula and you find A is equal to $24.39. So you put $24.39 for 20 years and eventually you will have $1,000 which you want to save. Let's see example for uniform series compound amount formula. We have a deposit of $100 is placed in a saving account at the end of each year from 2000 to 2009. This saving account earns 8% annual interest. The future value of this account at the end of 2009 is, please note, we are putting each year at the end 2000 to 2009. So it becomes actually 10 years of payments. And n is over here 10, and we just apply this formula and we get the future value. This is an interesting example. Let's look at that. Present value of delayed annuity. This example, present value at the start of year 2000 of an annuity of $1,000 per year, extending from the end of 2005 until the year 2025 with 10% interest. Payments occurs at the end of each year including 2025. This would be a 21-year annuity with the present value at the start of 2005. So first what we do is we find out the present value at year 2005, and then once this becomes a single payment, then we can use a single payment formula, present worth formula, and bring it back to year 2000. Let's see how we can visually think about it, these payments, and then I will show you and tell you about this, how this is a very practical example. So let's draw this cash flow diagram. In the year 2000,